Hello, everyone, and welcome to our panel. Today, we will talk about, in this panel, we'll talk about the various frameworks and languages in which you can create the mobile applications nowadays, and about their advantages and disadvantages. So, hi, my name is Alin. I'm the mobile community manager at Kotlin and Swift. And our mobile community includes various technologies, such as native iOS and Android, but also cross-platform technologies such as React Native or Flutter. Together with me today, I brought specialists in different platforms. Radu here is specialized in Android, having over 8 years experience in developing Android applications using both Java and Kotlin. Anka is an iOS developer with over 14 years experience in development, and in the late year, she made the transition to Flutter. So she has a unique point of view of an iOS developer and also a Flutter developer. And last but not least, Grazian is our specialist in React Native, having over 13 years experience in full stack web, but specializing in the last years in React Native, developing mobile apps in React Native. So we, from all the various cross-platform solutions, we chose Flutter and React Native for this discussion, being, from our experience, the most mature and the most requested platform nowadays in the market. So let's start with a short description of these cross-platform solutions for those of you who don't know them in details. And during our discussion, you can feel free to add comments and questions using the Q&A section, and we will reply to them. Or if you have a point of view that's different than ours, of course, you can also access the Q&A section and leave it there. So, Anka, what makes Flutter great?
Hello everyone. Welcome to our talk. From my point of view and my experience with Flutter, what I discovered is that Flutter is a cross-platform, indeed, a cross-platform UI tool nurtured by Google, so released by Google, but currently it's open source. And it does compile the one source code that it has in Dart. This is the language that it uses. It compiles. It has the ability to compile it into native code that runs into native platform-specific code that runs then on iOS, Android, macOS, Windows, and Linux. So they were focused more on the mobile development, but recently they added support for desktop and also for web. It's going to, I think it's going to be released pretty soon. So yeah, having this in mind that it natively compiles to platform-specific applications, and then this is still faster, so it doesn't cut off the quality or performance, or not in a noticeable way anyways. What I also like is that it has a declarative UI. It allows us to write the UI in a declarative manner. And when I saw that, I said, oh, my eyes are really thankful for that. So coming from iOS development, using the storyboard like sieves, it was I thought that was a real overhead, and the declarative UI seemed that simple for me. And also, it has really nice features for speeding up the development. I can use for testing the hot reload. This is while we are developing and writing code and want to test it, then we run the app in debug mode several times. And with hot reload, you just want to run it once, and then for subsequent changes, you don't need to restart the app to rebuild it. The changes are automatically reflected in the UI in almost all cases. So I won't say it works 100%. It also has a lot of So for the UI side, I think everything is a widget in Flutter. So any UI element that you see that is displayed on the screen for an app is a widget. Also, the layout it is done with widgets. And the nice thing about this is there are a lot of pre-made widgets that come with the Flutter framework. There is the widgets library, and also there are if you want more platform specific design, you can use the material widgets that complies with the material design rules, and also the Cupertino widgets that follow the Apple human interface guidelines. So this offers the developers the ability to write beautiful applications that looks as much natively as possible. Also, it has it comes with a rendering engine. I will tell you more about this. That is C++ base. It's the Skia rendering engine, and this also allows for fast rendering of the UI. So all in all, I like it. I like it also that it is open source, and it is a big community and increasing community that helps with many other custom widgets or packages or even plugins. So I think that answers for now the question. Or if you want, so yeah. So my experience with Flutter was really nice, and I found it that for me as a developer, it helped me in the process a lot.
Yeah, and also React Native is open source, and it has an even bigger community. So why do you think? I mean, also backed by a very big company, Facebook. So Gracian, why do you think React Native got such a lot of traction nowadays?
Well, yeah, hi. Actually, React Native is a platform built to allow developers the ability to create native applications by using JavaScript language, and this is the main feature. So you're using actually the same designs that React uses. So if you actually access React Native's website, it has a bold statement right on the landing page: learn once, write anywhere, which is appealing for JavaScript developers that started to perform full stack tasks without switching the programming language. So we are doing both front end, and after that we can also do back end tasks. So to fill in the gap, React Native comes to the rescue. So it fills the mobile native part that was missing. The nice feature, it's kind of recent. Microsoft actually is working on a project that will allow desktop applications for Windows 10 to run of course, on desktops, tablets, and so on, using React Native. So they are actually rebuilding some parts of React Native to make them even faster, rewriting them in C++. And the nice part is that they are also using rewriting for Mac. So we will be able soon to write React Native applications that will be deployed both on Apple, iOS, Mac, and Windows. So we are covering a lot of ground here. Yeah. More about React Native. So it started in 2013 as an internal project in Facebook, as you said. It got really fast. So in 2015, the first official release was published. And even if it didn't reach until now 1 point version, it's still on V0 point something. It has a huge community with a lot of projects in production. So if you are interested to make a project that you would like to push in production, do it. Don't stick to the version part. When it's best suited, well, we'll talk a lot more into details, but usually it's best suited when your team it's almost full of JavaScript developers, as I said. When performance is not that important, I think that we will also touch this part. And of course, when you want to create an application really fast. So basically, this is a
so for rapid prototyping, it's a very good solution.
And of course, it has the bells and whistles, as Anka said. It has fast refresh, incredible development tools, and also an incredible community and support.
This is like a battle. Everything you have, we have it too.
Yes.
So Radu, in your experience as a native developer and a cross-platform hater, do you think cross-platform solution will ever be better than native solution, or at least reach the same performance?
So first of all, hi everyone. So me being the last to talk, I want to welcome you all to our Programmers Week, like Cognizant's largest tech event. So I'm seeing a lot of attendees here, so I'm very happy all of you joined. Now, going back to me, I am not a cross-platform hater. I actually find them very interesting, and I'm looking for use cases for them. But when it comes to native, right? You mentioned performance, and it really depends a lot on what we understand by performance. But if you take it just simple engineering steps, what you learned in engineering school, the more complexity you add to a system, the worse it will perform, right? So whenever you wanted to optimize something, you start from the top level up until you can't optimize anymore, and you go lower and lower and lower, right? If you want to do the most optimal code, go write assembly. Nobody does that anymore. I agree, correct? But at the same time, when you're adding React Native, when you're adding Flutter, you're adding engines to all of this. Of course, there's going to be performance penalties. You do get that write once, run everywhere. Agreed, that's super awesome. And that's, I think, the biggest selling point for cross-platform. But as Grazian said, yeah, you have to pick your solution based on the problem you want to solve at the same time. We can talk about performance. We can also talk about security. The more layers you add to a system, the more vulnerable it may be, because you have to look at all of the layers there and understand what the problems are, right? Mobile is not new, but it's not old either, right? So we're learning from other tech. I can speak against web, but web has been way before native Android and iOS, right? So we're learning from them a lot. Yet again, Flutter and React Native, they're new. They're newer than native, but yet again, we're learning new stuff from it, but we can't forget about what means to go native. When you go native, you have that expertise of 10 years plus, right? We can't talk about expertise when we're talking about Flutter and React Native because they're too new. We haven't had enough time to experiment with them. But yeah, of course, you can get better FPS, better memory consumption if you go native, but at the same time, it depends who's coding your app. I've seen native apps that are memory hungry, that do not respect, that cause memory leaks, or have poor FPS. So definitely quality trumps everything. But when it comes to performance, if you've got a high performing team, native will always have the better performance, no matter how much you try to bring cross-platform to have the same performance as native. You're always going to have that extra layer of complexity, right? It's going to make development faster, but you're always compromising because engineering is compromise, right? And even though you're doing Flutter, React Native, Cordova, or any other, you're still gonna need native. In 90% or more of the cases, you can't get away from this yet, right? You still need it. So yeah, that's my opinion.
So yeah, performance is an interesting, it's an interesting topic, but also security is one. For example, in React Native, the JavaScript code is not compiled. So Grazian, what are some solutions? Because not compiled code can be a security breach if you look in the assets folder and you see the plain JavaScript code. So I know in some of our projects we improved this. So yeah.
Yeah. one solution would be to obfuscate the code, and there are multiple security approaches, but yeah, basically you're not as secured as using a React Native application. So in some cases, a pure native application. So in some cases for sensitive areas, you actually rely on a native module. So you are building a native module, you are exposing that module into the React Native world, and from there on you can continue with your application if you want to go that way. So as I said, React Native allows you fast prototyping, and in some cases this is an incredible good mix. You are building secured blocks in pure native, and exposing them in React Native to continue the fast development.
So one approach would be having both, right? Native and
yeah,
for some screens and React Native for other screens. Because if you think about it, there are some screens that doesn't really make sense to write them twice, like preference screen or profile screen, or screens that are not that complicated and also have static info more.
Yeah. Well, from my point of view, I would go the other way around. I would write everything in React Native and only secured high sensitive information.
Yeah, talking also about performance, I know that Flutter has an interesting way of rendering the UI, unlike native and React Native. So how does this, Anka, affect the performance?
Yeah, so I would add that also, as we've mentioned here, is really new. So first version was released in December 2018. So it's almost 2 years. For the UI rendering, it uses an engine that is called Skia. It's a graphical rendering engine that is optimized for 2D. Rendering, it's written in C, and it is agnostic of the platform that is running on. So Flutter is Flutter widgets. Flutter, it renders and it lays out and paints it by itself. It's his widget. It paints by itself every pixel and every layout on the screen. What it needs from native side, it's only a canvas, a texture where to render the widgets. So that makes it, so there is no bridging. So it doesn't try to find the equivalent on the platform side. Like for instance, if I have a button widget that I want to render, the SDK won't try to find the equivalent, let's say UI button on UIKit. No, it will render by itself. It will paint and lay out the pixel, every pixel of the widget on a canvas. It only needs a canvas from the native side, and this is done with a so-called platform embedder. That is done when this setup part of the project. So from this point of view, we don't have any bridging between the Flutter and the host platform. So that makes it faster from, if we compare with other cross-platforms frameworks. And because it is written in C++ and this embedder is written in Objective-C, it is quite faster. Sometimes it can be quite even faster than Swift. Not than Swift UI, but than Swift.
Mm-hmm.
So it can render like 60 frames per second. So whatever I've experienced so far with the apps that I worked on, the scrollings look natural for me almost. I mean, I didn't saw any noticeable differences, or maybe for sure it depends how you design, how you decide to architect to write the code. It implies many things, but if everything is done properly, I didn't see any penalty in performance from this point of view. I can't say otherwise because this is what I noticed.
So actually, you don't have a view hierarchy, right? You don't have a view hierarchy. Everything is flattened, so that's a huge performance improvement.
Yes, yes, and it's for instance, what I liked when I saw when I write Flutter first, and I saw even if it was released in 2018, it was you could run the code on iOS 9. Swift UI was released last year, so when also iOS 13 was released, and Swift UI which will only run on iOS 13 and onward. You can't run Swift UI on iOS 12, for instance. So what I mean, it doesn't depend. This way of rendering the UI doesn't depend on, because it doesn't try to match with the UI element on the other side, on the native platform side. So it makes it independent of any iOS updates, for instance, or changes in the current UI views from UIKit. Of course, if some new UI components comes in, Flutter has to add support, or if you don't want to wait for support for the new UI elements, you can run it yourself, write it yourself. Sorry.
Mm-hmm. So that's another con for both platforms, waiting for the official releases that comes up with every iOS and Android update.
Actually, you don't. You can like start to do this before the general release, while the new operating system is still in beta. So you can have an idea what's going to come next and try to address. But that depends, being open source, that depends on the community availability to do that. To go shoulder by shoulder with the latest changes on the platform OSs.
So for React Native, Etienne, I know you, as opposed to Flutter, you generate more views because you need them for both platforms. So I think that makes, and you also have the bridge. I think that today makes React Native the, let's say, worst, on the last place on the performance scale.
Yeah, well, if you compare it with native application development in Flutter, it kind of is. So and this is actually due to its underlying architecture. The communication between the UI native side and the JavaScript code is performed, as you said, using a bridge that actually is an asynchronous communication done by using callbacks and emitting events. Yeah, so that would be a performance issue. Another one, as you mentioned, is that actually the view hierarchy. So if you go and check the view hierarchy, you will see that it's huge in some cases. So this is one thing that will chew up your memory and the processing of your mobile device. But there are some good news, of course. So because React Native inherited some of the practices from the web, they now realize that they can improve some parts. So regarding the view hierarchy, actually they are trying to flatten everything. So one talk that I saw was a discussion actually regarding how to get rid of layout only views. So that would half on everything almost with no performance implication. And another big thing would be a code name project called Fabric. It's a huge refactor of React Native, and we'll have to see. So this needs to be tackled by the React Native team, It's something that came right after Flutter came on the market, because they saw that Flutter can do things a little bit better, and they engaged in full production architecture, re-architecture. So they are working there intensely, and the promises are very, very nice. So this re-architecture would imply actually a new bridge, simple API, and faster refreshes of the UI.
Got it. Yeah, thanks. That's, yeah, the future sounds good for React Native also. Also, I saw another advantage for this is that web developers can quickly catch up with React Native. So in your experience, when you did this transition, let's say, was it easy? Was it hard? How was it?
From web to React Native, I didn't heard.
Yes.
Yeah. So yeah, from my point of view, the hardest part, because I started 4 years ago, was at that time the setup. But once I got over the setup, the initial desktop and configuration, so I can have a working mobile application on my devices, that was editing. So from that point on, because I've used React and JavaScript before, it was seamless from my point of view. Every day I added a new thing in my skill set. So working with native parts was pretty easy. I had to check the documentation, and that was it. Yeah, of course, after the first release, I had to learn something more about the native part, how you do a release on the iOS and so on. But there are things that actually are interesting, and makes your life as a developer more fun. So the switch from web to a React Native, actually mobile application, was pretty easy from my point of view. And one thing is we have a lot of colleagues that actually switch from mobile devices, from mobile development to React Native. And I thought that they would have a struggle there, because they had to learn React and the way the React Native works. And actually it was the way around, because they learned extremely fast how you can develop a React Native application, and they enjoyed the declarative way of doing things in React Native and the tools. So I think that both web and mobile developers can use React Native to make mobile applications really fast.
So the learning curve is good.
Yes.
What about you, Anka? You did a similar transition to Flutter from a native developer. How was it for you? Was easy?
Not that easy, because we started in the team that I was at the time. We wanted to integrate Flutter in an existing native app. So there are lots of ups and downs, because the support from Flutter side for this was not that good at that moment. But for the setup of a new project, let's say if you want to do from scratch a new project, I found it pretty easy. You just have to install the framework, let's say the latest version of Flutter framework, and then you just need to, of course, run Flutter Doctor, for instance, to check whatever other dependencies are in place, and if not, it's easy to update everything you need. And then you just use the Flutter create command and specify the name of the project. This will create everything you need. It will also create an Android project, and then a runner project, and an iOS runner project. Yeah, it's all these projects are called runner, no matter what project you're working on. This is something I didn't like, but that's it. You can then just run from command line, so that there are good toolings for that. Just run Flutter run. That is just the name of the command, and you have to run it from the project that you are from the folder that project you are in, and you have the app on a simulator running, of course, with nothing And then it just
so the setup.
That's the setup
Setup
part.
is
And
easy.
then the setup is easy. Then you need to run the Dart code. For me, it was like easy to migrate from Swift to Dart code.
But what about the new ways of doing things? Widgets, also the state management. So that's a different mindset. Yeah.
Yeah, this is a change. Yes, exactly. So I moved away from the imperative way of doing things, and understand the declarative UI. So in Flutter, or in this paradigm, the UI is a function of state, and every widget had a build method, and that method should return the UI that it's needed at a moment for a given state, or it should rather render for any given state. So that was pretty interesting. There are a lot of packages and support for state management and Flutter. So they for instance recommend the Flutter provider, but there are other ways of managing the state. So it was, there were colleagues in the team that had more experience than I did, and it was easy to learn from them. And it's true, you still need native knowledge. For instance, if you want to release the app in store, or if you want, if you need something that needs to be platform specific, and Flutter, for instance, can't access directly the camera or open a URL for native side, and for that you need to write code on native side, and or use already existing plugins for that. But that means also native code. If you want to run it yourself, it's pretty easy using platform channels. So there are ways of communicating between the Flutter app and the host app, let's say the host app, the native app. You can use message channel or method channels. It's a synchronous communication. And
so all in all, we would describe it an interesting experience, an easy experience. You would do it again?
I would do it again. So yes, it was a learning curve, but I did really learned about declarative UIs that I didn't know anything about until that point, and also this new design pattern, let's say, about Redux. And I think this will help me with the Swift UI, because they also embrace the declarative UI paradigm, and also there is state management in there. So it's a gain, I think, for me.
Cool. Yeah, so that's nice to see, because I see in the late couple of years, both Apple and Google took the direction towards multi-platform development. We have Google adopted Kotlin that works also on mobile and backend, and also Flutter that works web and mobile soon, let's say. Also, Apple adopted Swift and made it open source, which is highly unusual for Apple. And now they're also running like Swift UI that targets also the web. So in your opinion, do you think that in the future we'll use the same language both for backend, front end? I mean, when I say front end, I say mobile and web. I don't know, Anka, if you can talk a little bit about Vapor. That's an interesting twist to the Swift code.
To the server side. I don't know.
What do you think? I mean, will you use Swift everywhere? Do you think we'll end up using Swift everywhere?
It depends. For instance, it depends on the business logic of the application. I think if we want, if we target an application that will run, we know we want to touch all the Apple devices. We wanted to run it on iPhones, iPads, watchOS, TVs, Apple Watches, Apple TVs, then I would definitely go to Swift UI and Swift language. That makes sense. If for instance, we target to reach the phone users mostly, then and the features that we want to implement doesn't require I don't know to have access to many services on native side, then I would go with Flutter and Dart language. But we'll see what will happen on Apple side also, how Swift UI will evolve.
So you're not sure yet. We're not sure yet.
I will keep the doors open. Sorry, I'm not like that
confident.
And no, I mean I'm not. I don't want to stick too much to just one technology. I want to know more from more technologies, because based on the type of the application, what's the target public, and we can choose the best. And of course, this is I guess forever debate between the product owners and the developers. They want to deliver as fast as possible, like if possible, like yesterday. So they come with the requirements, and then they ask about the timeline and how much it will take to implement. And if they see an opportunity to reduce the development without cutting, I don't know, from features or from functionalities, then they will go for that. So there's also negotiations here, and of course, we as programmers, we have to take care of our skills and not compromise too much.
Yeah, I mean, it's also a problem of costs here. So I think that's why cross-platform solutions gained a lot of popularity in the last years, because they reached the performance pretty similar with native at, I don't know if half the cost, but let's say an improved cost to reward ratio. So yeah. But on the other side, for the React Native, it seems like JavaScript took over the world, right? We have Node.js for the backend, we have React.js, we have React Native. So is it? I mean, how much code could you use? I mean, can one team build both, or possible all three? I don't know.
Yeah, it depends. It depends on the project. I did a workshop last year when I switched from web to React Native. I try to switch as many people as possible. So yeah, to convert them. But yeah, when I tackled that workshop, I started thinking about the common ground between native and web. So every library that I've used in that workshop were libraries that actually support both of them. So style components, navigation, and so on. So if you structure your entire project thinking of both worlds, you can actually reuse a lot of code. So Anka said about something about Redux. Well, Redux comes from React. It was one thing that actually pushed everything into a new era, let's say. So there are things that actually are reused in React Native. So a lot of libraries from web are reused in React Native, and vice versa. So we can reuse a lot of code. And if we think actually that we can integrate some other, I don't know, third-party modules like React Native Web to convert our code into web code, that's a nice feature also. But it highly depends on the project. If you want a project that is at the peak of the performance that React Native can deliver, and you also want that part on the web part, it's hard because you have to do
So would you
all
say
kind of improvements.
30%, 40%, something
No,
like that?
more than 60.
More?
Yeah,
Okay.
more.
So apart from the UI, you can use almost
Yes,
everything.
yes.
Okay. We have
If
a
you
question here. Yeah, go ahead. No. Finish your sentence.
So if you think that, if you consider basic application architecture, so you have the business layer, the state management, and so on, and you have a fairly small part, the UI part. Okay, if you abstract that part also even more, so you don't rely on native components and you make them as abstract as possible, you actually reuse much of that part also. So you are actually building only a proxy between what to render or not, and that's it.
Okay.
I'm
Yeah, so the
surprised.
question was, yeah, go ahead.
I'm surprised to hear that you're calling the UI layer very thin. Usually, a lot goes into the UI layer. So, and it depends on the framework itself. But generally, you're gonna see the business logic very nice and tight and unit tested, and the UI is huge, not abstract in any way when it comes to all platforms, right? And a lot of complexity just to do maybe not so complicated things, right?
Well, as I said, it depends how you structure your application. So if you're building up the application and the components with this thing in mind, you're actually composing generic components, right? And all the business logic that you actually add there, it's reusable. So you're only rewriting those small parts that are composing the the finish screen.
Okay, agreed.
Okay, so we have one question. What do you think about PWAs, progressive web applications? Well, I know they have some limitations. For example, you can't put them in App Store, and most of the downloads and most of the users come from App Store. If you look at all the revenue targets for all the big businesses. Another limitation, I think, it was push notification. Any other thoughts, Grazian, on why you shouldn't or when you should?
Yeah, well, when I tackled PWA, I had a lot of issues with, I don't know, small things like camera. So when I had to use the camera for, I don't know, Safari, I had to use a thing. For Chrome, I had to do something else, and so on. So it's nice, but you have to do all these quirks for things that are pretty simple. So if you are writing HTML and JavaScript, why don't you write React Native? And you have the full native support. So yeah, from my point of view, writing PWAs, it's hard. It's not as hard as it was 2 years or 3 years ago, because Safari added a lot of support now. But yeah, it's not as easy as it looks.
And if you think about it, how we mobile developers 2-3 years ago thought that PWAs are gonna take over the mobile world, well, they didn't. So that blew over.
Yeah, you're right. Talking about languages that can reach multiple platforms, Rado, I know the JetBrains team working on a concept of Kotlin Multiplatform. I mean, Kotlin already runs on backend and also on Android apps, and Kotlin Multiplatform aims to run also on iOS devices. So, what's the status there, and how do you see this project and this initiative?
Yeah, so it's interesting when you look at both mobile platforms, they both adopted very new high-level programming languages, right? We have Kotlin on Android, we have Swift on iOS. And if you look at them, they're fairly similar. So they're like super similar in a lot of ways. And if you have a mature team, you're gonna see that if they communicate well and business requirements are understood, when you look at the code, they're almost a reflection of each other. I actually worked on a project like this with a well-rounded team about 2 years ago. And it came up with Kotlin Multiplatform, right? You were asking. You also said I'm a cross-platform hater. I'm actually a JetBrains fan. Like JetBrains has brought us some awesome tools from IntelliJ. I'm not talking about Android Studio, but IntelliJ IDEA is awesome, and Kotlin is super cool, right? So if you look at it, they actually learned a lot from a lot of languages. Swift did that too, and that's why they look so similar. Dart, unfortunately, when I started learning Dart, I saw that it's lacking because it's older than Kotlin and Swift, right? Dart didn't start with Flutter. It started with web apps. It started with backend for Google, right? So they actually used it for other things. And it's, from my point of view, not as evolved as Kotlin and Swift. Now, what Kotlin Multiplatform does is they actually had this project, like JetBrains wants to take over the world, right? So they think of the entire software ecosystem, starting from your IDE to the actual software you make. Now, when you talk about Kotlin, they actually cross-compile it natively to a lot of platforms. And this is their purpose. They want to run Kotlin on everything. And that's pretty awesome. So on Android, Kotlin runs natively. They cross-compiled it to iOS. They cross-compiled it to web. You can use it on the backend. So they're actually trying to build an ecosystem here, which is pretty cool. If you look at the libraries that are built on Kotlin Multiplatform, if you look at Cater for networking, it's not necessarily mobile specific. It's not necessarily backend specific. It's somewhere in the middle. It needs to be abstracted better for both platforms, but they're actually trying to build a full stack from mobile to web to backend. Now, you asked about the state of multi-platform. This is where the problems for JetBrains come in, and that's a PR problem. They keep calling it experimental. Everybody says when a developer hears experimental, you're going to have those early adopters be super cheering, and you're going to have the other 99% of people saying, I'm not touching that. I'm pushing to production. Now, how experimental is it? From my point of view, they should not call it experimental. They're never going to get it perfect. But right now, it actually cross-compiles to mobile just fine for both platforms. And if you think it's like it was experimental 2 years ago, well, that team I worked with 2 years ago, when they saw that the code mirrored perfectly almost, and they were doing a lot of business logic, and it was kept very in sync, very much in sync. 2 years ago, they actually ported to Kotlin Multiplatform. They extracted a module with Kotlin Multiplatform, and it's actually, I think, one of the first products that was pushed to production using Kotlin Multiplatform, which is pretty cool. I can't take any of the credit. I was just doing code review there. I did not actually touch any of that part when they moved to multi-platform. But the truth of the matter is it was stable enough then. It depends, what do you care about stable enough? You need to test it out. And although it does cross-compile to everything, you're still going to want to do things natively, right? You're going to want to have to do things natively in iOS. And the problem, I think, there is, so if for web, you do get language bindings or bridgings with JavaScript, which is pretty cool. For iOS, you get it to Objective-C, as far as I know. And I think all of the Swift fans are going to hate that, and they're not going to like it. So up until JetBrains figures a way out to actually bridge to Swift, that's going to be problematic. But the most problematic thing is that for Kotlin Multiplatform right now, business logic is awesome because you can actually write it once and share it with all platforms. You can actually move beyond that. I talked about Cater. You can move your networking code to be cross-platform, and it's super stable. Cater, I'd use Cater honestly without ever going multi-platform. The same goes for SQLite, which is an awesome library created by Square. It's multi-platform, but I honestly use it sometimes instead of Room on Android, just because it's well thought out, right? And it's still multi-platform. The only problem that remains for the rest of the platforms is UI. UI has always been very different Android versus iOS. In the way it's thought out, in the patterns, the delegations that we use there are so different. So that's always been a problem. But don't know if you heard about Compose, but Compose is the next big thing that Android was pushing a lot, and it's going to get out of alpha soon, I think, for Jetpack Compose. But JetBrains announced it wants to take it to iOS, it wants to take it to desktop development, it wants to take it to web. When that happens, you're going to have declarative UI, and let's face it, Flutter did not invent declarative UI. I think JavaScript was one of the first languages to actually use declarative UI, right? So we're learning one from another. but Compose is taking it to declarative UI that has a very good chance of becoming multi-platform, right? So let me share my screen just real quick to show you 3 snippets of code. I'll let you guess which language is used where. So you just have a counter app, right? You're displaying the counter and you have 2 buttons to increment and decrement. This is one platform. This is another platform, and it's still readable and almost similar. And this is yet another platform. So we have 3 platforms that are writing code that's super similar. And this is actually doing UI.
So in order should be Dart. This
Okay.
Dart, the first one. This I don't know it, but the last one is Swift UI.
Okay.
Yeah.
And this is Kotlin Compose.
The other one is React. Yeah.
No, it's not React. It's Kotlin composable. Okay.
Yeah. So
Yeah.
this is.
They look very similar.
And honestly,
But React looks almost the same. Yeah.
yeah. So Grazian, tell me if this doesn't look like React a lot. Because no, it doesn't.
No way. Sorry.
Okay. So at the point where all of these, let me stop my sharing because I think I proved my point. That when you get to a point where all of these high-level languages become so close to each other, and you get one solution that could go multi-platform, I think it's the way to go. I'm not saying that the future of mobile means Kotlin multi-platform, because let's face it, I'm never gonna make predictions. Everybody's sunsetting a lot of things without notice. So I'm not even touching a prediction right now. But honestly, they're getting so close one to another and learning a lot from each other that at some point in time, although we're going to be using different languages and frameworks, it's going to be easier for us to keep things in sync, right? Because when we build an app which is meant for multiple platforms, you have web, Android, and iOS, you don't want 3 products, you want 1 product. And you want to make it easier for developers to actually keep in sync. You have to give them the same nomenclature and the same like dictionaries, right? So honestly, we have too many big fish on the market to say that one's going to win because they're all colossal there, right? But I think they're all heading towards kind of the same direction.
Yeah, so I have an interesting quote from the president of Touch Lab. He said that shared UI is the history of pain and failure. Shared logic is the history of computers. So yeah, Kotlin Multiplatform has a unique way of doing it, letting everybody do their own UI however they want, but sharing the business logic. That's interesting. Okay, yeah, cool. I mean, we have 7 minutes left. We have one question from Adrian. Radu said Compose is coming to desktop. What do you think about desktop? Will everything be web and Electron forever now, or will native code make a comeback? So, I don't know, Radu.
I don't think that's
me either.
that's not gonna die. Definitely not gonna die, but it's not gonna have the same popularity as it used to, like in the 70s, 80s, 90s, right? Now it's all about mobile web. It's about fast access. But honestly, are we talking from our phones right now? Or are we on our desktop apps, right? So there is some critical software that is gonna stick to desktop, and it's gonna be there for a lot of time. So if you wanna have a good cross-platform solution, you can't ignore desktop, right? We all have one at home. So,
Yeah, and also,
Graziano,
yeah, one thing is that I saw that there is migration. So we tried to create one app and view it on all our devices. So one thing was create a web application and view it in a web view or wrapper on a mobile phone, and do the same thing on a desktop. But I saw that the trend actually is going towards creating high performance dedicated applications by compiling them into that particular platform. So all the frameworks that are now coming are actually indicating that they will create better code, better applications for that particular device. So no more wrappers and so on. I would say that Electron and web views will be used, but for extremely simple applications.
So compiling, for example, JavaScript, let's say, into native desktop code and run it like a native app. Yeah, that's. I mean, I see, or even in our company, the demand for desktop apps has gone down a lot. So yeah, looking for alternative solutions there. Yeah, so yeah, we talked also about imperative UI. I think that's an interesting way that the platforms tend to merge. And what's interesting is that let's say this cross-platform move came from the community, from Xamarin, let's say. There were like Cordova, which was open source. There were a lot of initiatives from the community because they didn't want to make an app and have two different teams or two different languages and so on. And in the last years, the big players, as the big fishes, as Radu said, came into market and they were forced to adopt this new trend. And for example, Apple is known to be very inclusive. Now even Apple starts to become more exclusive. I mean, more open to the world, let's say, by opening up Swift and also moving to all the ecosystem. I know there's a project in the iOS community that compiled Swift to Android. so again, the community is pushing even Apple to go to multiple platforms. So that's an interesting thing to do. In my opinion, I think it will always come to the preference of developers. Different languages have been around for a lot of time. Maybe somebody will compile in the future Ruby code to mobile. So it will come, I think, I don't think somebody will win. Every developer will have their flavor. Yeah.
The good part is that, as Radu has shared, the good part is that Kotlin, Swift, and Dart will be so that similar. It will be easy for us developers to jump from one side to another. So if the platforms won't emerge, then at least it will be easy for us to. Maybe not that easy for me to jump to JavaScript, but that's impossible.
It's pretty similar to that. So I think, yeah, even the languages now resemble. I mean, if you think about it, Objective-C was so different than Java. Now they're really the same. So I think the concept of write once, run everywhere, I think it's wrong. You won't get performance and everything if you write once and then run on all platforms. I think a better concept is learn once, as Grazian said, learn once, but then write for each platform some specific things to make it more performant. And it can be JavaScript, it can be maybe Kotlin for multi-platform. And I think if you know Kotlin and you know Android, it's pretty easy to learn also Swift UI, and then you can play with both platforms. I think this concept it's the directions to go. I don't see any other questions. Hope you found it interesting. Thank you for all listening to us in our debate today, our discussion. Thank you, Radu, Anka, Grazian, for participating and sharing your thoughts.
There is one more question, Aline.
Yeah, one more thing.
Yeah. What do you
Go
think
ahead.
is the greatest challenge? I'm not really sure regarding what. What do you think?
The greatest,
yeah.
The greatest challenge in the
maybe for cross-platform to have success. I don't know.
Oh.
Yeah. I mean, yeah. The greatest challenge would be, I think, reaching the same performance and security as the native part. I mean, that's the thing to do, because as Radu said, when you cross-compile some code into another code, the machine also will add. It won't be as perfect as the humans write it yet, but that's this challenge.
I trust machine-generated code more than my code, honestly.
if you look at it, is not that good yet. But yes, in the future, I think that's good. That's gonna be solved. So yeah, thank you all. Hope you enjoyed it. Have a nice day.
And watch Programmers Week.
Bye-bye.
Have a nice day. Bye.